Your application is slowing down. Users are complaining. Response times are spiking. And somewhere in your infrastructure, something is breaking under pressure. I have seen this exact scenario in enterprise environments, in federal government systems, and in fast-growing startups. The problem is real. The stakes are real. And today, I am going to show you how a senior cloud engineer actually diagnoses and fixes it across AWS, GCP, and Azure. My name is Austin Jones. I am a senior cloud engineer and AI systems architect and the founder of Mr. Cees AI. Let us get into it. Picture this. It is a Tuesday morning, a business gets a call, their web app is timing out, customers cannot check out, the support queue is blowing up, engineers are getting paged. Nobody knows exactly what is wrong yet. Is it the database? Is it the servers? Is it the network? Is it traffic? This is what pressure looks like in the cloud, not a clean textbook scenario, a messy, real-time problem where people are watching, money is on the line, and you need answers fast. The first thing a senior engineer does is not panic. You open your observability tools, you look at your metrics, you read the story that your infrastructure is already telling you. Let us talk about what that story looks like. Before you touch anything, you investigate, you look at CPU utilization, memory pressure, network throughput, database query times, error rates. You check your load balancer logs. Are requests even reaching your servers, or are they timing out at the edge? You check your auto scaling groups. Did your infrastructure try to scale up and fail? Maybe you hit a quota. Maybe your scaling policies were too slow to react. You check your database. A slow query under normal traffic becomes a catastrophic bottleneck when you multiply it by 10,000 concurrent users. This investigative process is the same whether you are on AWS, GCP, or Azure. The tools are different. The thinking is the same. And that thinking is what separates a senior engineer from someone who is just clicking around, hoping it fixes itself. On AWS, you open CloudWatch first. You look for the spike in the metrics timeline, you check your auto scaling groups, you look at your EKS pods if you are running Kubernetes, you verify your application load balancer is healthy, and you check RDS for slow queries. On GCP, you use cloud monitoring and the 4 golden signals: latency, traffic, errors, and saturation. You look at your GKE cluster health and your VPC flow logs. On Azure, you start with application insights for end-to-end request tracing. Then you check your AKS node pools, your Azure SQL DT utilization, and your application gateway backend health. Now here is where Terraform changes everything. Instead of manually clicking through 3 different cloud consoles every time something breaks, you define your infrastructure as code. Your auto scaling rules, your load balancer configs, your Kubernetes node pools, your database replicas, all of it is written in Terraform modules, stored in version control, and deployed through a pipeline. When a problem hits and you need to scale up, you update a variable, and Terraform handles the rest consistently, safely, and with a full audit trail. You can use the same Terraform module across AWS, GCP, and Azure with different provider blocks. That is infrastructure portability. That is what enterprise teams need. And in government environments especially, every change needs to be tracked, reviewed, and approved. Terraform state files, plan outputs, and change logs are exactly what your change control board needs to see. Now let me tell you what this looks like inside a real organization. When an incident hits, you open a ticket in Jira or ServiceNow, you document what you observe, you capture your initial hypothesis, you link your monitoring dashboards. Changes to production do not happen without a change request. Even in an emergency, you document what you are changing and why. This protects you, your team, and your organization. After the incident is resolved, you write a post-mortem, not to blame anyone, but to understand what happened, what you did, what the impact was, and what you are going to do to make sure it does not happen again. This is what separates professional cloud engineering from just fixing things and moving on. Documentation, traceability, and process. That is the enterprise standard. Here is what I want you to take away from all of this. Cloud engineering is not about which logo is on your console. It is about solving business problems. When your app slows down, that is lost revenue. That is damaged trust. That is your users going somewhere else. A senior cloud engineer's job is to understand those stakes and to build systems that hold up under pressure without breaking security, without busting the budget, and without creating new problems while fixing old ones. And if you are trying to break into tech, this is what the real work looks like. Not just getting a certification, not just watching tutorials, but understanding the actual problems, the tools, the process, and the business consequences behind every single technical decision. I have done this work in federal environments, enterprise organizations, and growing startups. The thinking is always the same. The logo on the cloud console changes. The standard of excellence does not. If your business needs cloud infrastructure that can actually handle pressure, built right, secured, and scalable, go to MrCeesAI.com. That is my agency. We build cloud systems, AI automation, and enterprise-grade technology for serious organizations. And if you are building your career in tech, TechPassportApp.com is where you start. I built it specifically for people who are serious about this path and done guessing at the road ahead. I am Austin Jones. This is The Real Work. Drop your questions in the comments. I read every single one, and I will see you in the next one.